I wanted to go over it. Z is the easiest one. Z plus 5 equals 5. What does Z have to be? So if you don't want to show any work for Z, I'm perfectly fine with that because it's pretty simple to see. 0 plus 5 equals 0. But when you get to other things like the Y, so I want to change color this. When you get to the Y, you actually need to show a little bit of work. So 3y plus negative y plus 1 equals negative 9. I'll combine like terms. 2y equals negative 10. So y equals negative 5. Raise your hand if you got that. Good. Good. All right, now let's do x. If I'm dealing with x, that'd be this one here. So my equation is x plus 2 plus 3x equals 10. For x equals, subtract 2, I get 8. X equals 2. Any questions on those? Okay, so that's the practice of solving for x, y, and z. All you have to do is, remember, make your equations. All right, so now that we've done that, let's go and turn to the front of our spiral notebook. And today's objective, determinant and Cramer's rule. Determinant and Cramer's rule. So here's our first problem. We only have 4 problems today. And a determinant is just a number that matches with that matrix. So I can actually do just a little bit of math on a 2 by 2 matrix and come up with one number that represents that matrix. And here's how you find the determinant of this one. Let's do it by hand, and then I'll show you how to do a 3 by 3 by hand, and then I'll show you how to do it in the calculator. Because doing a 2 by 2 by hand is very quick, very easy. Starting at the top left, I make a diagonal to the bottom right, and I multiply those two numbers. 7 times 3 is? Then I subtract the other diagonal. 2 times 2 is? And so my answer for my determinant is 17. 17. Now, what I want you to do is to write yourself a little note. How did you get those numbers? Because if you're looking back, you may not remember where the 21 came from or the 4. Okay, so take a minute, write yourself a note. So now what I want to do is to find the determinant of my 3 by 3. So if I do exactly what I did on the last one, and I just use my 2 diagonals, did I use every single number in my matrix? No. And if you notice with the 2 by 2, I used every number, right? Well, it's important that I use every number. So what I just showed you does not work for this 3 by 3. What we have to do is we actually need to copy over the first 2 columns again. So I'm going to copy right beside this matrix, 4, 5, 1, 3, negative 7, and negative 2. So a 2 by 2 matrix is very quick, very easy to do by hand. A 3 by 3 actually takes a little bit more effort. So now what I'm going to do is draw in my diagonal. So I have this one, and this one to start with. And notice as I highlighted them all, I actually highlighted every single number. See how technically in here I didn't highlight the 5, 1, and negative 2, but they're highlighted out here, aren't they? So I've used every single number. So what we're going to do is we're going to multiply the first diagonal that I did. 4, negative 7, and 2. What does that make? Negative 56. I'm going to put that in parentheses with a plus sign. And now I do the next diagonal. It's my favorite. Yep, that's why it's my favorite. Anytime there's a 0 in there, I really like those. Because it doesn't require any thought process. 1, 5, and negative 2. Negative 10. Notice I put plus signs between each of those. So I added those diagonals, but now I need to subtract, like on the last one, diagonals going the other way. So now I'm going to make these 3 diagonals. So I have 1, -7, and 1. That makes -7 plus 4, 0, and -2 plus 3, 5, and 2. You forgot the 3 there, Madison. All right. So now I combine. -56 plus -10 makes -66 minus -7 plus 30 makes 23. So I have -89. -89. That's the number that represents that 3 by 3 matrix. Okay? Well, now let me show you how to do this actually using the calculator. Now, if I give you a 2 by 2 on homework, and let's say you don't finish it in class, you can do a 2 by 2 very quickly, very easily by hand, right? But 3 by 3s, I'll let you do them always in the calculator. How's that sound? All right, so the first thing you need to do, enter that matrix C into matrix A for me. So I went to second matrix. I went over to edit. And I clicked enter, and I edited letter A to be that 3 by 3 matrix right there. And I'll give you a second to catch up. So now that we've entered our matrix C, we actually need to get completely out of there by hitting second quit. We're back to the home screen. If you have anything on your home screen, clear it. And we have a blank canvas to go off of, so it's just a nice clear screen. Okay, go back to your matrix again. So go to second matrix. And this time, we haven't used this math category a whole lot yet. Actually, we haven't used it at all. So let's go over and look what's there. We have several things in here. We have DET. What do you think that stands for? Determinant. It's actually the most used thing for matrices. So that's why it's right here under determinant. We have dim, we have fill, we have identity, random M, augment, matrix to list to matrix, and so on. We need the first one. So we're going to click enter on it. And it's saying, well, what do you want to take the determinant of? So we need to tell it matrix A. So we're going to go back to matrix again and click enter on letter A. So now, I'm actually telling the calculator, go ahead and find the determinant of A. And if I click enter, it does it for me, and it gets -89. Any questions? Your calculator does a great thing with that, finding that determinant. Now, how do I use determinants to actually help me in math? That's where we're going with Cramer's rule. So here's your next problem to go ahead and write down. Now, it does say use Cramer's rule to solve, but what if it hadn't? What are some ways that you know to solve this already? Okay, I can get y by itself and use substitution. Okay, what did you say? Elimination. We have one more method. If I do get y by itself, I can do one more thing with it. I can graph it. Well, now I'm giving you a fourth item you can use. Okay, called Cramer's rule. So what you're actually going to need, you'll need 4 lines. 1, 2, 3, 4. I'm going to put the letter X in the middle. I'm going to put the line here. So I have 2 lines on top, 2 lines on bottom. Just some of you I know are those neat people, and if you're off balance a little bit, it's trying to mess you up. That's why I'm telling you, you need 2 lines on top, 2 lines on bottom. So I like to deal with the bottom one first. And notice I put 2 straight lines. Those straight lines actually mean find the determinant of this matrix. It does not mean find the absolute value of the matrix. It means find the determinant. Now normally if you see 2 straight lines and just a number in there, it means find the absolute value. When you see an entire matrix in there, that's where it's different. So on the bottom of this fraction, I'm actually going to write the coefficient matrix. those are the numbers in front of the x's and the y. So this first column will be the x's, the second column will be the y. So my first column will be a 2 and a 3, and the second column will be a 1 and a negative 2. Does that make sense to everybody? Okay, so that's my coefficient matrix. Go ahead and write yourself a note on how you filled that in, where those numbers came from. Now, on top, I'm going to write another 2 by 2 matrix. But what letter am I looking for? X. I'm going to replace the X column with the numbers that this is equal to. So the 1 and the negative 23. I like to call those my answers. So I'm going to replace the X column, because that's what I'm looking for, with the answer column. 1 and negative 23. Now this column over here stays exactly the same. I do not replace it, I just keep it exactly how it was. So 1 and negative 2. So then write yourself a note on how you filled in these top matrices. So girls, you should have negative 2 minus negative 23. Minus a negative is a plus, you should get 21. Boys, you should have negative 4 minus 3, which is negative 7. Then if I divide the top by the bottom, I get negative 3. I found x already. Any questions? Now I know technically I can plug this back in to find y, but we're practicing Cramer's rule, right? So let's fill in Cramer's rule for y now so we can practice that. So I'm going to go back, I'm going to look at my coefficient matrices here. Which of these two columns am I filling in? The first column or the second column? I'm going to fill in the second column because that's the y column. So I'm going to fill that in with the answers of 1 and negative 23. What about the first column? Do I change it at all? No, it stays exactly the same. The top one. Now, the bottom. What's the answer to the bottom already? Not negative 3. Negative 7. You already did all the work, right? If once you show it once for the bottom, I'm good. You don't have to show it a second time. It's going to be negative 7 every single time. Okay, find the determinant of the top now. Did you get 7? As your final answer once you divided it. I got the determinant was negative 49. 2 times negative 23 is negative 46. Minus 3, negative 49. Divided by negative 7 is 7. So my answer is negative 3, comma, 7. Does that make sense to everybody? Any questions? Now, I'll be honest. If I'm looking at this problem, I'm going to think elimination's a little easier. That's just me. Some of you may, after you've practiced Cramer's rule a few times, you may think it's easier. But let me show you our next problem here. It's going to be a 3 by 3 matrix. Go ahead and take a minute, copy that down. So we're going to solve for the letter x. I always like to fill in the bottom determinant first. I always like to fill in the bottom determinant first. Go ahead and see if you can fill it in real quick. have 1, negative 2, and 3. 3, negative 6, and 5. Negative 1, 1, and negative 2. Now I need to fill in the top. Now I'm going to need to fill in the top. Which column will I need to replace? 1, 2, or 3? Somebody raise your hand and help me out. 1. Since I'm looking for the x, I have to replace the x column with the answer. So 1, negative 3, and 4. What about the other 2 columns? Do I switch them around, rearrange them? What do you think? Keep them the same, just rewrite them. 3, negative 6, and 5. Negative 1, 1, and negative 2. Now, I told you you get to use a calculator for 3's, right? I'm not kidding. If you're a guy, please do the top. If you are a girl, please find the determinant of the bottom. So if you're a guy, find the determinant of the top. If you are a girl, find the determinant of the bottom. Alright, guys, yell out what you got for the first top here. Negative 8, you guys all agree? Girls, yell at the bottom. The answer is 2. Now, several of you raised your hand to actually tell me, hey, I did the bonus, right? Is that a lot easier? But don't get me wrong, it's still a lot of work, isn't it? Like writing down all 6 of those lines and then just typing it in the calculator. The hardest part is making sure you write it down correctly. Now, if I said to find y, do you guys feel comfortable finding y without actually going through it? Okay. What would stay the same? What part would you not have to ever rewrite again because you know the answer? You would know the bottom's negative 4 the entire way through, right? All right. So, I think a 3x3 matrix is pretty easy this way. Now, when you take your quiz on Wednesday, I'm not going to say find x. I'm going to say which of these is the correct setup for Cramer's rules for the letter x. And this will be one of the answer choices. That way I can make sure you set it up correctly. So, at this time, pull out a clean sheet of paper for essential work. If you are a person that needs to walk up to get paper, get yourself a small stack so you don't have to walk up anymore. And put it in your binder. Here are your 5 homework problems. Here are the 2 problems that you must show work for. That's Cramer's rule. That's it. The other ones, if you want to use the calculator, go ahead. How's that sound?